Greetings, everyone. This is Jeff Wilkerson, professor of physics at Luther College, bringing you the next in our series of what to look for in the night sky. We're talking about the week of June 23rd this time around. So let's start with the moon. Early on, the moon's new. So we got a good dark moon week where we could see a lot of things. But by the time we start to work our way through, the evening of the 27th, the moon will be about 10% full, probably just a little bit less than 10% full. So you've got a nice, beautiful crescent moon. And that beautiful crescent moon sits one fist width, 9 to 10 degrees to the east of Mercury. And so this gives you a chance to find Mercury. The Beehive Cluster, M44 in Cancer, open star cluster lies right between them. So get your binoculars out and find the moon and then scan slowly to the west. See if you can see the Beehive Cluster and see if you can find Mercury. And so we got a few days here where it's going to be far enough from the sun that you might have a decent chance to be able to do this. You might be able to see it with your naked eye. You got to get this timing just right. Let the sky get dark enough that the Mercury and the Beehive Cluster can pop out for you. Now, a couple of nights later, it's going to be a little bit easier. The moon's gone, but the Mercury will have moved, will cut the distance to the Beehive Cluster. That's like 3 degrees in there. It will have cut that distance by a third or more. And so it will be a little farther from the sun. This whole region sets about an hour and a half after sunset. So you need a good western horizon. And after sunset, 45 minutes, it's starting to get dark enough to be able to see these things. So that gives you the window that you're looking for. See if you can find the Beehive Cluster in Cancer. See if you can pull Mercury out from there. Use your binoculars and then see if you can see Mercury with your naked eye. This is a good chance, good target here. But on that night, the evening of the 29th, as we're getting late through the week, Sunday evening, the moon is about 25% full. So it's gone from just less than 10% full to a quarter full. And on that night, the moon will pass, just as it's getting dark, the moon will be separating for me. It depends on where you are in the world. For me, here in the middle of North America, as it gets dark, the moon will be separating from Mars, but it will pass less than a degree from Mars. So in other parts of the world, you might have a better chance to see a beautiful red Mars and a beautiful crescent moon right there together in the sky are going to form a really nice pair. Mars has pulled away. Been tracking Mars next to the bright star Regulus in Leo the last few weeks, and it has now pulled 7 degrees away, 7 degrees to the east of Regulus. So now there's quite a bit of separation. There's 2/3 of a fist width that separates Regulus from Mars right there. So this is all good. The other thing with the planets that we've been tracking, Venus rises about 3:30 in the morning by the end of the week, by the time we're getting here. So Venus has been a morning object for a while. It's had a hard time as the daylight has sort of eaten away the night on both ends. Venus has had a hard time separating itself from the sun to be really easily, beautifully visible. It's there now, basically. By 3:30 in the morning, you're going to see bright Venus as a wonderful morning object. Neptune and Saturn are still in the morning sky, still a nice pair. Get your binoculars out and see if you can see Neptune in the same field of view as Saturn. We've been talking about that every week. That's going to, they're going to stay together there for a little while. Neither one of those moves very fast across the sky. So that's all good stuff. Let's turn our attention. Last week, we talked about planetary nebulae in Cygnus. And we looked at the ring nebula. We talked about planetary nebula in general last week. But let's go back to Cygnus and look at Cygnus a little bit more. So this is kind of a mess. Cygnus we think of as the Northern Cross. Deneb is the big, bright summer triangle star that's up here. And Alberio, we talked about last week, is the beautiful binary star, double star that sits down in the head of the swan, the base of the Northern Cross. And there's the cross part across there. Gamma Centaur is the star that that runs right at the heart of the cross right there. It's a bright 2.2 magnitude star. So you got this bright 2.2 magnitude star, the Gamma star in the constellation of Cygnus. Now, as we move off to the west, we come to Delta. Delta is a pretty bright star, 2.8 magnitude or something bright star. It's a binary star that has a 6th magnitude star and a 2.9 magnitude star there together. Only about 2 arc seconds separates these stars, so you need good stable seeing, and there's enough brightness difference between these two stars that it's a little bit hard to see that faint companion when it's that close to the brighter star. So it's a good test for your telescope. You got an 8 or 10 inch telescope, should be no problem if you've got decent skies. You got a 4-inch or a 3-inch telescope, you might be wanting to check. This is a good test of your optics to see how good they are and how good your skies are. So there you got a nice binary star to pick up on the way by. That's not our main target here in Cygnus. I don't know if we have a main target, but as we move on, we can pop up this direction to theta. As we do that, we pass NGC 6811. That's an open star cluster. And it's a fine open star cluster. It sits less than 2 degrees from Delta right there. So get your telescope out, low power eyepiece, low magnification. You got a Schmidt-Cassegrain telescope or a reflected telescope like that. You're talking about a 30 or 40 millimeter eyepiece. Will allow you to slide from Delta to this sort of faint, sort of big, sprawling open star cluster. It's a nice, beautiful open star cluster. We see a lot of open star clusters in the plane of the Milky Way galaxy, and we talk about them from time to time here. Here's a good example I don't think we've probably ever talked about before. We pop up to theta. Theta is a faint star, 4.5 magnitude. You need pretty dark skies to reliably see that without optical aid. But we move up this direction, and theta sits less than 2 degrees from Iota, about 1.8 degrees from Iota, and Iota then on up to Kappa, and these are a little bit brighter. Kappa's a 3.8 magnitude star, so we're talking about 3rd and 4th magnitude stars here. And Kappa is on up, that's about 2.5 times that distance. It's about 2.5 degrees, or a little more than 2.5 degrees from Iota on up to Kappa. So we can track these stars in Cygnus that we don't often track as we move up this direction. Now, one of our main targets here, one of the reasons we're doing this is we've talked about planetary nebulae last week as end states of low mass stars, and we looked at some great examples. There's a fine example here next to theta. About 1 1/3 degrees is all this is. Remember, 1 degree is your finger held out at arm's length, and so 1 to 2 finger widths away from theta up this direction as you do this mark is NGC 6826. I think it's sometimes called the blinking planetary nebula. So this is a planetary nebula like we looked at last week. And I think I'm having fun re-exploring some of these planetary nebulae and thinking about where you can find different planetary nebulae on the sky at different times and whatnot. So I'm enjoying this. So I have a feeling that as the summer wears on, we're going to continue looking at examples of planetary, some big and bright, beautiful examples of the Dumbbell Nebula, M76, and Perseus, these sorts of things. Those are two different things, M27 and Vulpecula, and M76 and the Little Dumbbell and Perseus. But we'll look at different examples of those as the summer goes on, and then some more obscure ones that maybe or maybe not you've looked at them before, and to think about these. Remember, the planetary nebulae, these are stars that have puffed off these outer layers. They've blown off the outer layers, the envelopes of the stars. And so if they're old enough, they've spread out enough, they're big enough to see and tell us not just a star you're looking at, but then they've gotten fainter as that material has dispersed out into space. When they're young, just after this has happened, they're still bright, but you can't tell that it's just not the star, that material's. So you got this sort of sweet spot, and then of course the farther away they are, the smaller they look and the fainter they look. So we have all of these things at play here. So these are often faint objects or they're bright objects, but they're hard to tell that they're not stars, that they're actually a disk of gas that's out in there. This is a pretty good example. You got an 8-inch telescope or a 6-inch telescope or a 10-inch telescope. You'd have no problem, I would think, if you've got decent skies, finding NGC 6826 and being able to see that it's a planetary nebula. So that's what we got for you this week. A pretty good week for thinking about trying to find Mercury. This is, Mercury's going to start sagging back toward the sun. This is your week to get out and try to find Mercury. The Moon and Mars make a really beautiful pairing right there. We still got Neptune and Saturn making a great pairing. And then we explore Cygnus a little bit more like we did last week with one good planetary nebula, one good open star cluster, a hard binary star, and trying to find some of the stars that we don't always look for in Cygnus. So that's it, everybody. As always, thanks for watching and have a great week ahead.